Okay, so this video is a little bit random, but I thought that it would be good to do a video on cross-validation just because cross-validation is such a quintessential um, variable in machine learning, and there couldn't be enough videos about it or ways for people to look at cross-validation from different perspectives. So this video is going to teach how to just an initial, very beginner introduction on cross-validation in Python. And the model that we're going to do cross-validation on is a random forest model. And I think that both these are important just because random forests are an important useful model in machine learning uh, because they generally have pretty good accuracy. Uh, so it's a good thing to add to your data science toolbox. So basically the first step in cross-validation that we want to do is to split our predictors and our response variable. Here we have a lot of data on wildfires, and um, what we want to be predicting is whether the wildfire was caused by human or natural causes. So basically our response variable is going to be data.cause because that's the cause of the wildfire, and that's going to be y. And our predictors are going to be everything except for the cause. So we can just do data.drop cause, and then of course the axis is going to equal 1 to indicate that we want to drop this on the columns instead of the rows. And our next step is to split into test and training data. So Python is super smart and it has a lot of things that you can do in one line that would otherwise take multiple lines and lots of different function writing. Uh, so the whole test and training, there's actually a function for that, which is test and train split that you can import from sklearn.model selection. And this function is super useful as a one-liner for splitting your predictors and your response variable into test and training data. Um, Also, just in case you aren't super familiar with what cross-validation is in general and why we're splitting into test and training data, the reasoning behind this is because um, we want to train our data on a separate data set than what we're testing to see if the data set is actually accurate. And this makes sense because the only way to see how well your model can actually predict something is to use data that the model's never seen before, and that's your test data. So that's basically the data that you're withholding from your normal your normal model training. Sometimes it's called the holdout set. But anyways, so the only arguments that the test train split function takes in are your predictors, your response variable, and the test size, which is just the percentage of your data set that you want to attempt to withhold so that you can use it to predict later. And you usually want this to be notably less than your training size, which makes sense because you want to be able to train your data set with as much data as possible to reduce sampling error and things like that. Okay, so our next step is to fit the model with the training data. So here we go. We don't want the test data to even touch the model when we're fitting it. So we can import our sklearn.ensemble, which has our random forest classifier. Um, so I won't go into the details about the different parameters that random forests have. But I will let you know that this 100 is the number of trees that it uses. So basically a random forest, and this is just a short summary, but basically a random forest is a basically a collection of different decision trees, and you can set the random forest to either take the mean or the mode uh, and, like final answer of these decision trees and use those to output your actual answer of the model. So it's a lot more accurate than just a single decision tree. Um, and it's a super useful model. But there's a lot more parameters to it, and it is more complicated than that. but just for the purpose of explaining cross-validation, um, we are just using 100 as the number of trees, the number of estimators that we're using in this model. But this is a variable that you can change to see if it makes your model more or less accurate. That's known as a hyperparameter. But we won't go too deep into that because that can get a little bit complicated. Anyways, so we have our training data, and we use that to fit our random forest. And then we have one final step, which is to calculate the error using our test data. So this has nothing to do with the, well, I mean, it's from the same data set, but it's separate from all of the training data. Um, and this is what cross-validation is. This is the step where we are actually doing cross-validation. So there's a lot of different ways to measure error, but that's what cross-validation is doing at the heart of it. It's measuring error. So there are many different ways to do cross-validation, different ways to sample the test sets, different folds of cross-validation that you can use. I'm not going to go into that because that conceptually is just a little bit higher up. And if you're just trying to learn and figure out what cross-validation is, uh, you don't need to be focusing on that yet, but it is the next step for understanding cross-validation. But there's also a lot of different ways to measure error. One very common way is mean squared error. That's often used um, in regression modeling. And then there's also root mean squared error. And then what is used here, it is super useful for classification models, is I think it's zero loss function. Um, yeah, it's a loss function. I think it's called a 0, 1 loss function, which is I'm not totally sure if that's the name. Um, but I'm pretty sure that's correct. And that basically just labels whether you, if you have, it basically does all of your predictions and then compares those to the real data values. And if they're a match, if you predicted the right thing, it counts that as a 1. And if they aren't a match, um, then it counts it as a 0. And then it takes an average of all of those values. And as you can see, or would assume from that, the average of all those values would give you the proportion of times you guessed the right answer. So for our model, we guessed the right answer 78% of the time. So considering our model was 58%, about 58% human-caused fires and about 42% naturally caused fires. The prediction of 78% is notably higher than that, and we can tell that our model is better than random guessing. Obviously, there are still some improvements we can make, and maybe collect some data that is a better indicator of whether a fire was caused by humans or caused by natural causes. But still, this is a good start, and we wouldn't have been able to prove this well without cross-validation. Cross-validation is also super useful for comparing different types of models. For example, if I did plug all this data into logistic regression, it wouldn't the return of the cross-validation score would be about 58%, which is a lot worse. So we know that for the sake of accuracy, at least, um, using our random forest is a lot better than using logistic regression. And we can also compare this to many other models. So basically, that's the gist of cross-validation and using it on a random forest model. Um, but I hope that you continue to explore this topic and that you enjoy your work on Python and with data science.